Oke, ini adalah IOC grup kami end of chapter 1. Oke, mari kita mulai. So this is for definition of primary sensing element. The definition is sense and converts the input signal to a move, convenient and practicable form. The output variable will be the input of the next element. So this output is converted and logs electrical signal. Next, this is a three type of errors. Number one is grace error, means fault of person using the instrument, such as incorrect reading, incorrect recording or data, or incorrect use of instrument. And grace error can be reduced by a proper meter and connection. Number two, random error are errors that remain after grace, and systematic errors have been substantially reduced. These errors are due to unknown causes. These errors can be minimized by taking many readings of each instrument and analyze statistically determining mean value. Number three is absolute. Actually, error is the difference between the expected value and measured value. Example for the formula is yn minus xn, where is E is absolute error, yn is expected value, and xn is measured value. So this is accuracy and precision. As you can see, this is the picture of accuracy and precision. So accuracy is the definition of accuracy is how close to indicating the actual value, like relative accuracy. A is equal to 1 minus yn minus xn over yn, and percent relative accuracy is equal to 100% minus 100 minus percent E, and equal A multiply 100%. So number two, precision is a measure of the consistency or repeatability of measurement.
Okay, this is for question 2. For A is the answer is 1 coil, 2 scale, and 3 is magnet. Okay, this is for B, 2 range DC ammeter circuit, and this is the circuit. C is the first range is 0 to 10 milliampere. Give I1 equal to 10 milliampere. Then IM equal to 2 milliampere and RM is equal to 50. Okay. RSH1 equal to IM RM over 10M minus 2M equal to 12.5. Okay, the second range is 0 to 25 milliampere. Give I2 equal to 25 milliampere. IM equal to 2 milliampere. Then RM is equal to 50. RSH2 is equal to IM RM over I2 minus IM. RSH2 equal to 2M times by 50 over 25M minus 2M is equal to 4.35. Okay, this is for question 2. A is 1 coil, 2 scale, 3 magnet. B is 2 range DC ammeter circuit. This is the circuit. Then C, the first range is 0 to 10 milliampere. Give I1 equal to 10 milliampere, IM equal to 2 milliampere, and RM is equal to 50. RSH1 is equal to Im times Rm over 10m minus 2m equal to 12.5. Okay, the second range is 0 to 25 milliampere. Give I2 equal to 25 milliampere, Im equal to 2 milliampere, Rm is equal to 50. Okay, this is RSH2 equal to Im times by Rm over I2 minus Im. RSH2 equal to 2m times 50 over 25m minus 2m is equal to 4.35. Okay, this is for question 3. A is the basic principle of the DC meter is the interaction of magnetic fields. The fields of the compass, a permanent magnet, and the field around the conductor, a simple electromagnet. The principle of AC meter is that the resistance and inductive reactance must very low. Okay, this is for B. RSH 1 equal to 3 over 100 minus 10k equal to 20k. RSH2 equal to 10 over 100 minus 10k equal to 90k. RSH3 equal to 30 over 100 minus 10 equal to 290. Okay, this is for C. The PPMC stands for permanent magnet moving coil, and it is also called as the Arsonval instrument. The PMMC works on the electromagnetic effect. A permanent magnet is used to produce magnetic flux, and a coil that causes the current to be measured moves in this field. As the pointer is connected to the coil, it gets deflected in proportion with the current. The operating principle of PMMC is when a current carrying conductor placed in the magnetic field experience a force. Okay, this is the diagram. The best construction of PMMC is shown in the diagram. A light rectangular coil wound on an aluminum frame is pivoted within the air gaps between the two poles of a permanent magnet and a cylindrical soft icon core. The light rectangular coil carries the current to be measured. Soft icon core provides formation of uniform magnetic field. The aluminum frame supports the coil as well as providing eddy current damping to pose for bronze springs called in opposite directions serve as leads for the current in the coil. The spring also provide controlling torque. This is for question 4. A1 allows the amplitude of electrical signals, whether the voltage, current, power, etc., to be displayed primarily as a function of time. The basic instrument for the study of all types of waveforms. Okay. 2 is used to visualize certain voltage waveforms. 3 can display the variation of a voltage waveforms in the time of the oscilloscope's screen.
So okay, next answer is C. The calculation will be like this. VPP equal to 3 times 2.5 volt equals 7.5 volt, and then the VP is VPP over 2
which is equal to 7.5 over 2, and the answer is 3.75 volt. Next is the times is equal to 3 times 100 millisecond, and the answer is 300 milliseconds. So next is the F is equal to 1 over 1 equal 1 over 300 millisecond, and the answer is 3.3 kilohertz. Next. Okay, next is question 5. So you can see the diagram, and this is how the calculation works, which is VA equals to VB. So in VA, the calculation will be like RT over R3 plus R1, and VB is R4 over R4 plus R2, and VA R3 multiplied by R4 plus R2, and for VB is R4 multiplied by R3 plus R1, and you get the answer for R1 and R4, which is uh, you will get the answer for Rx equal to R2 RT over R1, which is 15k and 40k over 20k. You will get the answer for Rx is 30k. Next question. So question 6, the answer is the wattmeter is an instrument for measuring the electric active power, or the average of the rate of flow of electrical energy in watts of any given circuit. Two mechanism of wattmeter. The wattmeter works on the principle that the current carrying conductor placed in a magnetic field experience a force. The wattmeter consists two coils. For example, the current and the pressure coil. The current coil connects in series with the load and the pressure coil. The current coil connects in series with the load and the pressure coil in connected in parallel. So this is the basic of analog wattmeter. The current coil is connected in series with circuit, while the potential coil is connected to in a parallel on analog wattmeter. The potential coil carries a needle that moves over a scale to indicate the measurement. A current flowing through the current coil generates an electromagnetic field around the coil. The potential coil has a general rule, a high value resistor connected in a series with it to reduce the current that flows through it.